We're going to go through this process of taking cubic equations and quadratic equations and how do we factor them. Those are the two we're going to look at. We're not going to go beyond 4 factors in grade 12 here. You may later on in your math career, but that's what we're going to start with. So we're going to be looking at 4 factors at most. And a lot of ours are going to be cubic equations because cubic equations are really common in nature. Cubic regression is a very common thing that happens. And knowing those factors really does help. And if you do take calculus next term, calculus really helps you find these factors because you can do things called derivatives and stuff and look for critical points. And critical points can be found using calculus techniques. But right now we don't know that, so we have to do it the longer way, basically, is what we're going to learn today. And that's a little bit of guessing and checking in there. Okay? So what is the strategy? Well, let's outline what we have to do. Okay, so what do we do to factor a polynomial? So the first thing we do, number 1, is we list the possible binomial factors. Okay, and we do this as kind of a subset underneath it. We do this by factoring the first term and last term. Okay, so we do a combination. And I'll demonstrate that. So that's the first thing we do. Okay, then the guessing and checking happens after that. So then we choose a factor and use the factor remainder theorem to see if there is no remainder. Okay, if that happens, then we know that it's a factor. Okay, so then we check it with the factor theorem, see if there's no remainder. If that is the case, then we are happy and proceed. Okay, we use synthetic or long division then to divide out a successful factor. We'll just say a factor because we don't need to say successful factor because if it's a factor it was successful, okay? If there's no remainder. Okay, and then we just, if it's a cubic equation, we then use quadratic factoring. If it's a quadratic one, we then repeat it. So then keep factoring if needed, as needed. So that's the basic strategy. We list the possible factors, then we start picking them and putting them into the remainder theorem to see if they work. Once we get one that works, we divide it out, and then we reduce down, and we continue factoring as needed until there are no more factors to find. Okay, so it's pretty short process in the terms of what you're going to do, but it can be very long depending on how many times you have to guess and check a factor, right? And how many times you have to divide something up. So if we have an x to the third or an x to the fourth, we can expect as many as 3 factors for the one with 3 and 4 for that one with the 4. So we can always keep that in the back of our mind. So what we're going to do today then is we're going to do, and we're probably going to spend at least a couple days on this in math. And this is the end of our unit, so it's a very short unit, just real quick, just how to factor basically. Okay, so what we're going to do today then is we're going to look at some examples, and then we're going to look at tomorrow, or I guess on Monday, a little more complex examples. So we're going to start out simple and then move into more complex as we go. But generally speaking, I find students do really good in this short unit. It's a nice short hand-in, a nice short quiz, so it's really easy to get. Okay, let's take a look at doing some examples. Let me pop up some here. Okay, so let's say we have this expression. Let's factor okay, I'm going to use the calligraphy pen here. Okay, let me choose one that'll factor out evenly. Okay, so let's say we got this one. We'll use a cubic one to start. So now we're going to just do examples with no number in front of this first term to start with today. So they're all going to be ones. Okay, just like when we did quadratics way back in grade 9 and 10. Okay, so step one is to look here and here. So we're going to look at the 12, and we're going to look for the factors of 12. And the factors of x cubed. Okay, well, x cubed is easy. It's just x, x, and x. So x, right? If you factored out that, it'd be x times x times x, right? So we know that the first factor, because there's no number in front, and that's why we're doing only numbers, a single number in front. We know that this is x. And then we're going to do all the possible factors of 12. So 12 is 1 times 12, 2 times 6, and 3 times 4. These are the possible factors of 12. So we're going to list the possible binomials with all these combinations. So it's going to be x plus or minus 1, x plus or minus 2, x plus or minus 3, x plus or minus 4, x plus or minus 6, and x plus or minus 12. Now, why is it plus or minus? Because you could have a plus value or a minus value working out, right? Depending on, because especially this one's negative, so you might be negative, one might be plus, one might be negative, so they're always plus or minus. Now, so our possible factors, so we're going to list the possible factors. Let's write that in, what we're doing, so we don't forget. So we're going to list the possible factors as binomials. Okay, now when I list them, I don't write it x plus 1, x minus 1. I just go x plus or minus 1, and I know that as 2. But you could do it like that. So we got x plus or minus 1. That's 2 factors. X plus or minus 2, x plus or minus 3, because these are all the factors of 12, x plus or minus 4, then 6 and 12. So we've got a possibility of 12 factors there, right? Sorry about that. 12 factors there. Okay, so now this is where we have to do some guessing. Like, okay, which one of these factors is going to work? X plus 1 or x minus 1? X plus 2 or x minus 2? So what we do in step number 2 is we choose one of those factors and we use the remainder theorem. Remember, the remainder theorem is you solve it to 0, plug it into the big equation, and if you get 0, it's a factor. So we're going to choose one. So now we're going to test the factors. Okay, so I'm going to do x plus 1. Okay, I'm just starting out with, I usually start with the x plus 1, x minus 1, because it's the easiest one to plug in. So we're going to use the remainder theorem. Okay, so let me move my block out of here. Okay, so now we're just going to do x plus 1 equals 0. So that means we're going to be plugging in x equals negative 1. Okay, and we're going to plug it into this equation up here. See if we get a 0. So go negative 1 cubed, 2 plus 2 times negative 1 squared, minus 11 times negative 1, minus 12. Okay, now if we get a 0, that means we have a factor. Okay, so we get negative 1 plus 2. Negative 1 times negative 1 is 1 times 2, plus 11 minus 12. Okay, that would be 1, 12, 0. Yes, it is a factor. Now don't get all happy. I know that was a factor because I did this one before, right? So I didn't luck out and pick the right one, but you might have to test a few times to get one, right? So it might take a little longer. But I knew that x plus 1 was a factor because I've done this example probably, I don't know, let's guess, 10 or 15 times in my life. I've used the same one probably. Okay, so that's a factor. So now that we know that it's a factor, we then divide it out. Now we can use, now we want to use long division or synthetic division. Most people choose synthetic division to divide out their factor because it's quicker. Okay, so now we use a division method, whichever one you like, to divide out x plus 1. Okay, so now I'm just going to use synthetic division. So okay, so now I'm going to take and I'm going to make my synthetic division line here. Okay, and then I'm going to plug in my expression. So my expression, if we remember, is this one up here. So it's 1, 2, negative 11, and negative 12. Okay, now we're dividing by x plus 1. We don't plug this one in because we're doing the same method the book does. We're going to multiply here and minus there. So we put a 1 here to do our division. Now, if we divide properly, we should get a 0 here because there's going to be no remainder. So we'll bring down the 1. 1 times 1 is 1. 2 minus 1 is 1. Oh boy, we got a lot of 1s. Okay, 1 times 1 is 1. Negative 11 minus 1 is negative 12. Negative 12 times 1 is negative 12. Negative 12 minus negative 12 is 0. Okay, so now we list our factors that we know for sure. Okay, list your factors. Okay, so we know that x plus 1 was the first one. And we now know that this is 1 less than x cubed. This is the next term, x. And this is the last one, the number. No remainder. And we can factor this. Okay, do we remember how to factor quadratics from grade 10 and 11? Probably. Two numbers that multiply to negative 12 and add to 1. Okay, we've got an x and an x. They've got to add to a positive 1 and multiply to a negative 12. So one has to be positive, one has to be negative. We're going to get a negative 3 and a positive 4. That's going to multiply out to a negative 12 and add up to a positive 1. Okay, that's our factoring of a quadratic from a couple years back in grade 10 and 11. Okay, so there's our three factors, x plus 1, x minus 3, and x plus 4. Okay, that didn't take us too long because I knew what the factor was, right? But sometimes you have to go through 2 or 3 of them with the remainder theorem to figure it out, right? But the process is pretty simple. So summarizing, if we go back up to the top here, the big one is look at the 2. Remember, we're only doing 1s in front. So it's always going to be x here, right? And then whatever this last factor is going to be the number here. And it's always going to be plus and minuses. And then we just choose one to put in the remainder theorem, hope we get a 0. If we don't get a 0, we throw it out and start again. Okay? And then once we get one that gets us a 0, we divide. We could use synthetic division or we can use long division, whichever we like better. I choose synthetic division because it's quicker. That's all. But if you understand long division better and like it better, do it that way. And then once I do that, I then know what my one binomial is and then my quadratic if I'm doing a cubic one. Now, if this was to the power of 4, I would still have to do this again, right? But we're going to start out with the smaller ones first, power of 3s. But that's pretty easy. Okay, let's do one where let's do one with powers of 4 to open it up. And then I'll have you do some simple, easy practice ones. So I've got another one here that I've made up. So let's factor x to the 4th. So that means we're going to have to do this twice at least to bring it down to a quadratic that we can factor. Okay, minus 4x cubed okay, minus 9x squared. And this is as high as we're going to go in the class. We're not going to do 5s or 6s or 7s at all. You might if you do calculus, but not here. Okay, plus 20. Okay, so that's a large one. So we can have as many, we're going to have, if this goes evenly, and it does, we're going to have 4 factors. So our first thing is we're going to look at the 20 and look at the factors of 20. So the factors of 20, if we think about factors of 20, we're going to have 1 and 20, 2 and 10, 4 and 5. Okay? Those give us our possible factors. So now we're going to combine these with an x. So x plus or minus 1, x plus or minus 2, x plus or minus 4, x plus or minus 5, x plus or minus 10, and x plus or minus 20. So there's our possible factors. All right. Okay, rather than me picking the one that I know is going to work, I'm going to get you to pick one. And then we'll see if you get lucky. All right. All right, Nancy, what are you going to go for? What are you going to go for? There's no pressure on you here?
The 4 plus or minus 4.
Okay, which one? Plus or minus? X. Nancy says x. Plus or minus? Plus 4. Okay. Equals 0. So this means x equals minus 4. Let's see if she gets it here. Okay, so minus 4 to the 4th minus 4 to the negative 4 cubed minus 9 to minus 4 squared. Ooh, let's see. Plus 16 times minus 4 plus 20. All right, let's see. Minus 4 to the 4th. Let's see what that is. 4 times 4 times 4 times 4. That is 256. And this would be also 256 here because we got 3 negatives. 3 negatives there and then 1 more. So this would be, okay, now we got 16 times negative 9. And we got 16 times negative 4. And we got 20. All right, that doesn't look like it's going to work, but let's just add them up. Okay, I get 324. Okay, so no luck with that one. All right. Who wants to try now?
Positive 2.
Positive 2. Okay, x plus 2 equals 0. So x equals negative 2. Okay, we got negative 2 to the 4th minus 4 times negative 2 cubed minus 9 times negative 2 squared plus 16 times negative 2 plus 20. Okay, so we got negative 2 times negative 2 times negative 2 times negative 2. Okay, so negative 2 times negative 2 times negative 2 times negative 2 is 16. Okay, this is negative 8 times negative 4, which is plus 32. This is 4 times negative 9, so this is negative 36. And this is minus 32. And this is 20. Oh, this looks possible here. Let's add it up. 16 plus 32 minus 36 minus 32 plus 20. 0. Holy smokes. Got in the second guess. Okay, so x.
Let's go.
So which one did we pick? X plus 2 is a factor. So Yay! All right, so now let's do our next step. So now we have to divide the x plus 2. Okay, so I'm going to make my synthetic division here. Okay, so now I got to put that big expression in here before I forget what it is. 1, negative 4, negative 9, plus 16, plus 20. There it is. That's a 20, by the way, not a 26. Okay, and then we're going to put plus 2 here. All right, so all right, 1 times 2 is 2. Negative 4 minus 2 is negative 6. Negative 6 times 2 is negative 12. 9 minus negative 12 is plus 3. 3 times 2 is 6. 16 minus 6 is 10. 10 times 2 is 20. 20 minus 20 is 0. Oh, there we go. All right, so then our factors are x plus 2 times, now we've got x cubed minus 6x squared plus 3x plus 10. Okay, so now we have to do the cubic one. Okay, so now we have factors of 10 rather than 20 at the back, right? So it's going to give us different possible factors. All right, so now we've already got x plus 2. Let's put it over here so we don't forget. Now we're going to do this one. So our possible factors, I'm going to change color so that we know we're doing a second step here. We're going to look at this one. So we got x plus or minus 1, x plus or minus 10. That's 1 times 10. X plus or minus 2, x plus or minus 5. So there's only 8 for this one, right? Because there's 1 times 10 and 2 times 5 for the 10s. All right. So we got x plus 2 already. All right, what are we going to pick? Don't pick. Oh, we don't have to pick 4s because there's no more 4s. I heard Delilah say x plus 1. Good job. Let's try x plus 1. X plus 1 equals 0, so that equals x equals negative 1. Okay, let's do that one. So negative 1 cubed minus 6 times negative 1 squared plus 3 times negative 1 plus 10. So this one looks plausible. This is negative 1. This is negative 6. This is negative 3 plus 10. Good job, 0. Okay, so x plus 1 is a factor. Okay, let's synthetically divide it now. Okay, I'm going to extend this page. Okay, I'm going too fast, just let me know. Okay, we make our synthetic division. Now remember, we're not doing the fourth one, we're just doing the cube one. We're just doing this second part one right here. So that's a 1. A 1, a negative 6, positive 3, and a positive 10. And then we've got a plus 1 here. Okay, so bring the 1 down. 1 times 1 is 1. Negative 6 minus 1 is negative 7. Negative 7 times 1 is negative 7. 3 minus negative 7 is positive 10, right? Because minusing a negative 7 is like adding it. 1 times 10 is 10. 10 minus 10 is 0. Okay, so now we list all our factors. So we choose the first factor that we got here that David guessed, and then the second factor that Delilah, I read her mind. So we got x plus 2 and x plus 1. Okay, and then this would be x squared minus 7x plus 10. Okay, so that's our final quadratic. Now we can factor the quadratic, two numbers that multiply to 10 and add to negative 7. Both have to be negative numbers because we have a positive here and a negative here. So they both have to be negative. So we leave these ones. Okay, and we got an x, an x. So negative 5 and negative 2 would give us a negative 7 to add in the middle and a positive 10 when we multiply them. And that's an example of doing a 4. All right. So 2 examples there, but probably the best thing we can do is just try a few. Okay, so to summarize the process, cubic ones will have 3 factors. Now, can you get a prime one? Yes. Sometimes you can try all the factors and none work. That would hurt, okay? It would hurt inside, right? So yes, that is possible. Now, on my hand-in and on my exams, there are no prime ones, okay? I don't know about the textbook, though, because sometimes they throw that in there to try to cause stress and stuff like that. But I know when I give hand-ins and stuff like that, it's just ones that work out evenly, okay? So we'll do some practice. We've got about half an hour. I'm going to give you a couple at least. So let me pop open my area here. I forget what page it is on. I wrote down that it's number 4, but I forgot to write down what page it is, so let me look it up in the book here. All right, so this would be right. Okay, factor thing. This isn't 3.3. I think. Next. What are the possible integral zeros of each polynomial? Why do they use such dumb language in the book? Use the word factor. Integral zero is the same thing as factor. State whether, okay, so. Okay, so I'm going to give you 2 to try. Maybe 3. We'll do 3. So this is on page 134. Okay, and number 5. If you do A, that one has factors, I hope. And okay, I won't look at E. They give you 1 to the 5th power. What a bunch of meanies. We're not going to do that one. How about just A, B, and C? 3 of them's quite a bit, but A is factors of 6, so it's just 1 and 6, 2 and 3. B is factors of 2, so it's just 1 and 2. And C is ugly, it's 16. It's 1 and 16, 2 and 8, 4 and 4. Right? All right, so you can work on those. We do not have math tomorrow, right? because you guys are doing your class that you do on Fridays?
I'm not gonna be here tomorrow, so for chemistry, I will be.
Okay, fair enough. I still need to do a bunch of marking in chemistry anyway, Nancy, so I might have to do some marking after I get back home from our volleyball stuff this weekend. All right. I hope that we're going to do some more ones with numbers in front of the x cubed next time. But only if people get this first. If people are getting this first, then we'll move on. If people are not, we will spend a little more time on this. Okay, this is the end of this small unit, so like I said, most students don't find this one too difficult, other than it's kind of long sometimes to find the factors. It just takes a little bit of time. Okay, so I'm going to